Hello and welcome to the presentation for Group 4 in IoT. We have implemented a smart home health monitoring system which monitors temperature, pressure, air contaminant, and dust data inside the home. And we use this data to provide input to the air conditioning system as well as perform some rudimentary data analytics to provide directed ads based on the data so as to reduce the cost of the whole system. So we currently have two devices deployed, one inside and one outside the home. So this is the front end for our application implemented at group4iot.cloudout.net. We enter the device ID for the first device inside the home, which is one, and see the data. So as you saw, we saw an ad as soon as we came in because we have set the system to show ads in what we have programmed to be lunchtime, and if it detects that the dust sensor has not given it a high reading during lunchtime, it is indicative of someone not cooking food today. So in such a situation, it will show an ad saying, looks like you're not cooking food today, how about ordering some instead? So if we click this, the ad shall go away and we can get back to our readings. This is for the device inside the home. So we can see it shows us the air quality data, and which you can see is very close to zero right now. So we were right in seeing that ad because there is no cooking event happening, and the dust particle density is very low. We can also see the temperature and humidity data inside. It's 25 degrees Celsius and 30% relative humidity. It's plotted on the same scale over time. Temperature in blue and humidity in red here. This is actual data coming from the device that we have deployed. Let's check the device outside and see what differences are there. We don't expect a lot of difference right now because we just placed it in an open window and there wasn't a large difference, but outside is definitely cooler. As you can see here, it's at 21 degrees Celsius. A slight difference in humidity as well. We can also monitor the same contaminant and particle dust density outside as well, which is plotted here. And for outside, we also have a bit of historical data which we have plotted in this historical air quality data chart, and blue represents higher data, a higher magnitude. um, Also, as a part of our system, we have implemented an input to the air conditioning system. So right now we have put in very rudimentary analytics that as you saw, the temperature inside was 25 degrees Celsius, which was warmer than outside, and we have set an optimal temperature to be 22 degrees Celsius. So we should expect something like a call to the air conditioning to be turned on to cool the room. And this is another file that fetches data from the server and performs analytics to give an input on whether we should perform cooling or heating. Right now we should perform cooling. This is working as expected. Another feature that we have implemented is that we can download historical data from the two devices that we have deployed. So if we go to this download link for the device outside, click on the download button, we get comma separated values as the data which we can download offline as well. Download linked file, and we can see the results in Excel if we want. There we go. A photograph of the hardware that we have deployed for measuring temperature and air contaminants data. This is the Raspberry Pi over here, and this is the board containing all the sensors. Let's have a closer look at that. So this is the air contaminant sensor. This is the pressure and temperature sensor. This is the humidity and temperature sensor. That's the dust sensor over there, which senses dust, LED based dust sensor. And this is the analog to digital converter that we needed in order to make the gas and dust sensors work.